We'll talk about today about how intelligence and automation can enable networks for higher speed. And we're talking speed here is not just higher bit rate or higher velocities or more capacity, but really how we get those networks to get ready faster, right? Faster time to market, and in the challenging world that we live today. So just to recap, I mean, things that we do and why we do that. I mean, what's going on with the world today? So we see the world change in terms of networks are being used. Users, human and machines, they need a better experience, right? And it's needed right now. So be that streaming Netflix or doing virtual reality or augmented reality, or even grandma zooming or doing WhatsApp, or kids learning from home. So this is all changing. I mean, this was not the case years ago, and even more now with the whole world is different than it was 2 years ago. And just on the grandma zooming there, my father, he has a phone and he plays with the phone and he does WhatsApp calls. And when I call him, he takes the calls on his hearing aid, which is connected via Bluetooth to the phone. So, and he's 82. So how much more connected people can be these days, right? Because he uses that a lot. So kids at home studying, we're having entertainment consumption at home and all kinds of applications. So how do we address that volume? How do we address that growth in terms of capacity, in terms of demand? Be that kids watching videos at home or Internet of Things, IoT with the machines needing to be connected, or even a live show. How long anybody has been into one of those, right? I miss those. A live show doing the filming and with the phone. So we'll come back someday. But when we do, the changes in capacity, in demand, in the network to increase the volume of data, they have to be fast, right? So, and if you look at the whole discussion about autonomous driving, right? The sheer amount of capacity that is required to have a vehicle connected everywhere and the streaming telemetry and everything. So, I mean, all of this capacity has to be sent to all kinds of places. But how much can we automate? How much can we make our lives easier to those ever-changing requirements, right? And we have started we as an industry, right, digital transformation journey. So, and we see that intelligence, data-driven automation is very much an enabler for all those changes. So if we have digital transformation, we can improve the customer experience. And these days, everything is on-demand customer experience. So how we do that? Because we need to provide new services. We need to have these new services managed in real time. And everybody involved in the delivery of those services, operations, IT, and networks, they have to evolve to enable all this new approach. So if we have to ideally manage the full life cycle of the service, this is what we have to try and do. And what the operators are thinking about, and how did they behave in the past, how they behave now, what are the drivers behind their decisions. So when they're deciding about technology, if you look at years ago, the traditional drivers were improved economics, so better price per bit, better cost. How do I optimize my asset utilization? So how do I have more capacity for the same infrastructure that I have in place? How do I keep my service going, right? Service availability. How do I keep pace with growth? And if you look at the models that we had in the subsea industry, was very much a traditional consortium cable, so multiple owners, each one with their own participation in terms of investment and capacity they can use. But now the world is changing, has changed very much. So the drivers that we see as new drivers are faster time to market. So have to be available now. The consumption now, I mean, the demand is now based on the consumption. So it's not like, let me plan for the next 2 years. No, there is demand now. How do I go and serve that demand? So the reaction time has to be much faster. Of course, all customers are trying to avoid becoming obsolete. So with the advanced pace of construction of new systems coming in, how do I keep my system with value in the industry? So We saw some discussions today about systems that have been around for a while. They're continuously getting modernized to be able to remain relevant. And in terms of the types of cables that we see, we have web scale cables, which are very high capacity, point A to point B, data center to data center. But we also have other players like global service provider cables. We had some of those speaking here today. And we also have some unique service provider cables like specialized cables, dedicated routes, regional routes. So we moved from one single model that served all kinds of applications into multiple models in terms of how we build submarine systems in the industry today. And just to put a little bit more complexity into everything, right? So if we look at the trends, and we talked about those today, they are great in a way that they increase flexibility and openness, but with that comes complexity, right? So we talked about some of those today. Open cables was one that was mentioned just in the previous session. So cables being built on the wet side and allowing different vendors to deploy their own technology on the terminal side. Also programmable modems. We heard two companies talking about those today, Ciena and Infinera. So multiple baud's, multiple knobs you can tweak to increase your capacity, to optimize your reach and your capacity. We also heard about STM cables, which is more fiber pairs. Also, maybe at the same time, we'll have some customers wanting less than one fiber pair, so just a fraction of that fiber pair, which will be maybe something like a spectrum sharing. And on top of all that, we have ROADMs in the branching units sitting in the ocean that can be reconfigured. So cables are open, the rates can change, more fibers, each fiber can have different directions, points A to B to Z that can be reconfigured. So this all brings a whole lot of complexity, right? Which is good because all this is aiming for lower cost per bit, more capacity. So this is good, but how do we cope with all that complexity, right? And on top of everything else, we have the world that we live today with COVID coming in, right? So years ago, we would discuss deployments, right? Which is a critical part of how we grow the industry, how we serve more customers, how we as an industry provide more connectivity. So we'd have, in normal conditions, we'd have some landing sites are easy, others not so much, but we can live with that. Capacity has to be delivered as per the plan of work, according to the schedule. We promised a date, we have to go and deliver by that date. And the demand was kind of predictable. So we could see, okay, last year was a growth of 30%, next year, maybe 35%, and you plan ahead. Now with the pandemic conditions, maybe you cannot travel for that location. Maybe if you have somebody traveling to do the deployment, maybe they have to quarantine for 14 days to come in and to come out. So all these concerns about health and safety come into play, and maybe customers at the same time, they're using more connectivity because they're staying more at home. They're doing more binge watching. They're doing more Zoom. We're all working from home. We're all participating on this event remotely. Normally, we would be in Buenos Aires or somewhere else just live, and we're doing this remotely. So how do we cope with those increases in demand? So we see that intelligent automation is the way that we can alleviate that. We can minimize those impacts because maybe we can add more capacity using automation. Maybe we can even optimize the capacity that we have on a single cable by tweaking and adjusting and running some testing to validate the optimal configuration for that cable. So maximize the assets. Imagine you have a cable that was supposed to have 20 terabits, and then after you do your intelligent automation, some testing, maybe you have 10% more. So this is savings. This is money in your pocket because you invested in those assets, but you can have more value from those assets. And of course, if you can have remote access to those resources to do the installation and deployment, maybe it's easier because of the travel restrictions. So if we put all that together, and if we have to start somewhere, let's start with the automating capacity turn-up and testing. So if we look at the lifetime of a subsea cable, so a life cycle, of a submarine cable when we are doing the deployment. So we have to install the SLT, so we have to go there, put racks, shelves, do the physical installation. So this is part of the deployment. But after that, we have a series of activities that are likely to be automated. So activating the spectrum, testing the channels, enabling those channels until we arrive to the ready for service of that system. If you look at how much time we normally have to dedicate for each one of those activities, right? So if you look at installation, yeah, we have to go and install, so that's there. The pre-commissioning, we have to go and configure a bunch of things. That's also there. And then commissioning and spectrum sweep. So commissioning is really optimizing that capacity, and spectrum sweep is really running some testing, changing the channels in different parts of the spectrum so you can maximize your system. If we automate some of that, what we have is that installation, nothing we can do because we need people to go there and do the physical installation. The pre-commissioning doesn't change either, but on the commissioning and on the spectrum sweep, we can greatly reduce the time we need to have a system ready for service. So, and if you consider all those complexities that we saw in the previous slides, lots of fiber pairs, lots of possible configurations because of all the branching units, lots of different rates and bauds and speeds, you need to automate. Otherwise, it's going to be taking too long to get those cables ready for service, and you're going to start to have impacts. Not to mention that this costs money to have those assets there without being ready to carry traffic. So we start by automating in an intelligent way the deployment, but we should not stop there, right? How do we keep using automation to improve the rest of the service lifecycle? If you look at the three main blocks here, so we have the first one, which is what we call plan to build. So creating the service, getting the network ready, building, configuring, getting this ready to receive traffic. And then the next one is order to service. Is once your network is ready, you're receiving orders from customers to activate capacity. So how do we automate that process from having a customer requesting, please give me 1 terabit from A to Z? How do you automate as much as you can that whole process? And finally, once that service is live and operating, how do you automate the trouble to resolve, which is things ideally will go well, but we know things at times will go wrong. So how do you have a process that can be automated to when something is wrong, how do you fix it very quickly with the minimum amount of human interaction to maximize the speed for you to recover that traffic? If you look at where we are now, right? So in terms of the whole life cycle and different stages that we see ourselves. So before it was pretty much human driven. So CLI, command line interface. So people would see something, look at screens. There's a light blinking. Let me go and fix it. Go configure, put some commands, fix it, move on. Now we are in the workflow driven. So there's still a lot of human dependency. But once something happens, there is a workflow that is already predefined. So the human operator, they know exactly what to do for every possible scenario. Next, we have the event-driven, which is some of the responses for the event are already automated. So people don't have to go and follow those scripts, but this is already pre-configured. But we see this is, it's necessary to move beyond that. So what we see the industry moving is from workflow-driven and event-driven to getting into machine-driven, which will be something similar to cruise control. So you get your car, you want to be so much at a certain speed and a certain distance behind the next car, and you can release the wheels, but maybe paying attention a little bit so you're safe enough that your car will run safely, will not change lanes, will keep the distance, but you still are driving the car. As the next step, we see something that will be similar to autopilot. So you configure what you want to happen, you click, you can look away, things will be fine. But how do we enable all that? So we have something we call the adaptive network, which is basically a cycle where we have a programmable infrastructure, which is the hardware and software running, connecting different elements in your network, but also they carry a lot of telemetry. So they have sensors that are going to be measuring information in that network and feeding all that into a intelligence and analytics layer that will use machine learning, will use big data, small data to do some predictive analytics And this will in turn be fed into an automation and control layer that will use that information to, based on some policies that were predefined, make decisions to adjust or to improve or automate certain functions of your network. So we call this the adaptive network, and this is what will enable networks to be more self-resilient, more self-aware, and even at one point, minimizing the need for interaction. You're still telling the network what they have to do in each of the situations. So it's not like it's going wild. It's not like Skynet taking over the world and the androids and all that, but it is something that will allow you to go sit back, relax, and knowing that your network is safe. And just to close up, what we see and where we're heading as an industry. So the subsea networks are evolving, and right now it's more than just capacity, right? It's more than just adding more bits. It's really going and automating things so things are more reliable and faster to deploy. We have SDN, the software-defined networks, something already real, so it's no longer a hype. So we see that as an enabler for all that automation that we talked about. And then finally, what we see is the evolution is, and we touched upon that in the previous panels, so a seamless network that is agile, that is smart, spanning land, sea, and cloud to provide the operators with a much better experience, and finally, the users with a much better user experience. And that's all I had. So thank you very much. I'll take a question or two if we have time. Otherwise, you can look me up and we'll talk more. Thank you.
Hay algunas infraestructuras y tendidos, perdón, que en la región que ya superan los 20 años.
Sí.
¿Qué diferencias de performance están viendo en estos tendidos y cómo ayudan desde Ciena a estos operadores que tienen una infraestructura más antigua?
Hay redes que están por ahí hace tiempos y lo que los clientes están haciendo es, una vez que la infraestructura está ahí, hay maneras de poner más capacidad, cambiando solamente las puntas, ¿no? Los terminales, los SLT, los modems, para darles un poco más de sobrevida, ¿no? Para que tengan ahí más competitividad en el mercado. Pero en realidad, cuando se tiene una red que es súper nueva, como las que están construyendo ahora en la región, el diseño de la planta submarina, del wet plant, fue hecho para la transmisión coherente que existe ahí hace casi 10 años. Y entonces la performance va a ser mejor, pero hay cosas que se pueden hacer en los terminales, pero llega un punto y la razón por la cual algunas redes están ahí retirándose es porque el costo de operación está más alto que la competitividad que tienen para ofrecer servicios ahí en el mercado. Entonces no es tanto el tema de la tecnología que está vieja, pero sí el costo para operar y el costo de vender los servicios. Entonces, ese es el tema que vemos ahí. Pero hay cosas que sí se puede hacer, pero son distintas. La performance de redes nuevas va a ser mejor porque fueron diseñadas para la transmisión que tenemos hoy.